Okay, now let us try to understand solutions showing deviation from Raoult's law, which are known as non-ideal solutions. So you can see non-ideal solutions can be of two types. One is the solutions showing positive deviation from Raoult's law. Another is solutions showing negative deviation from Raoult's law. Now when we say a solution is showing positive deviation from Raoult's law, you see in solutions showing positive deviation, the AA, that is the pure component A and the pure component B interactions are stronger than the new interaction. That means molecules of our AB are quite far compared to the molecules of AA and molecules of BB. In other words, we may say that the molecules are moving apart. It's a kind of you can say that it is a kind of bond breaking, right? Molecules are moving apart. Due to this, amount of energy needed to break the bond is less than amount of energy released during formation of bond. Therefore, the net heat change will be endothermic in nature, because amount of heat required to break the bond is more than amount of energy released during formation of bond. So delta H mix is greater than 0 means delta H is positive. That is, it is an endothermic process. You see, point-wise, if you have to remember, it's very easy to remember. All are greater than 0. But when it comes to practical application, that you need to understand what does it really mean. Now, delta V mix is more than 0. That means volume of the solution is more than volume of pure component A and B. If I take an example, if I take 10 ml of A and 10 ml of B, we expect the final volume to be 20 ml. But those solutions which showing positive deviation, the volume of the final solution will not be 20 ml, rather it will be little more. It may be 20.2 ml, it may be 20.3 ml, like this. As I told you earlier also, it may sound weird. How can volume increase? But it does happen. Okay. Why does it happen? Because now the molecules of AB are quite far compared to the molecules of A when they were in the pure form and B when they were in the pure form. So as a result, what happens? PA, that is, we know for Raoult's law, PA is equal to PA naught chi A. But for non-ideal solution showing positive deviation, PA will be more than PA naught chi A and PB will be more than PB naught chi B. That you will find in the note also, which I have sent you earlier. Now, solutions which show negative deviation, the scenario is just reverse. AA and BB interactions are weaker than AB interaction. That means molecules of solute and solvent are much closer than the molecules of pure A and pure solvent and pure solute, A and B. That means it can be considered as if some bonds are forming. And you know, when bonds are formed, energy is released. So you may notice here delta H mix is less than 0, which means the process is exothermic reaction. Now, since the molecules are coming closer, what will happen to the final volume? Final volume will be less than 0. I mean, the difference in the final volume will be less than 0. So you may suppose give you an equation, 10 ml of A and 10 ml of B are mixed and the final volume is found to be 19.8 ml. What kind of deviation does it show from Raoult's law? So you see, if 10 ml of A and 10 ml of B is mixed, what is the expected final volume? The final volume is expected to be 20 ml. But in reality, how much you got? 19.8. Now, if you take the difference, 19.8 minus 20, how much do you get? Minus 0.2. That means you are getting the value in negative. So, delta V mix is less than 0. Less than 0 means negative value, right? So, this is happening because volume of solution is less than volume of pure components A and B. So, those kind of situation where we get, these are called solutions showing negative deviation. As a result, what will happen to this PA and PB values? PA value will be, going back to the table, yes, you can see PA will be less than PA naught chi A, point number 1. PA will be less than PA naught chi A and PB will be less than PB naught chi B. The less than sign is not very clear. Please write it. So delta H mix is less than 0, delta V mix is less than 0. It's very easy to remember when it comes to learning, remembering the points. But only remembering will not do. Nobody will ask you to write an essay on positive and negative deviations. Okay, you'll be given practical situations and you have to explain that. So then you can add one more point, as I told you, from the previous table. This point number 6, from point number 6 here can be added here. They under positive deviation they form solutions minimum boiling azeotrope and they form maximum boiling azeotrope. We'll try to understand what are azeotropes in the next topic itself. And you can just to increase the points here, you can bring some examples, refer to the textbook, you will find some examples of solutions showing positive and negative deviations. So let us come to the azeotropes now. Okay, here we have some examples, solutions showing negative and positive deviation. You see, azeotropes are also called constant boiling mixture. That means if you have two components A and B, and as I told you, solutions means they are mixtures, and mixtures, the quality is you can be able to separate them. Now if I take water and say alcohol, how can I separate them? Both are liquid. We can separate them by a process called fractional distillation. And what happens in fractional distillation? If I am heating a mixture of liquids, the liquid which is having lower boiling point will start distilling off first. And once the entire liquid, say component B or A, whatever, is distilled off, the temperature of the solution is not expected to increase. And once entire component A is distilled off, then the temperature of the mixture will start increasing again, and when the temperature of the next component B, which is higher, is reached, it will start distilling again. You may take 2, 3, 4 as many kinds of liquids as a mixture. You can separate them by fractional distillation, provided they don't undergo chemical reaction and they don't have same boiling point. Okay, but in azeotrope what happens? A stage will come, suppose I have taken component A and B, B has started evaporating out, distilling off. As a result, the concentration of A and B in the mixture is changing constantly. A stage will come, at a particular percentage of composition, they will form an azeotropic mixture, means both A and B will start boiling together. That means you cannot separate them any further by distillation. Such situation is called azeotropic mixture. So there are two types of azeotropic mixtures. One is minimum boiling azeotrope, another is maximum boiling azeotrope. So as the name suggests, you can understand maximum boiling azeotrope will have the mixture will boil at a higher temperature than component A and B, the boiling points of A and B. And minimum boiling means at lower temperature than component A and B, and maximum boiling means they will boil at a higher temperature than A and B. You can understand with the help of this graph. You see, this graph shows the dotted lines, they are showing ideal behavior, which we have already drawn while understanding Raoult's law for volatile components. Now here you notice, here we have taken chi A equal to 1, chi B equal to 0. So if chi A equal to 1 and chi B equal to 0, that means we have taken pure component A. There is no component B. And the pressure exerted due to this A is PA naught. Correct? And here on this point, we have taken chi A to be 0 and chi B to be 1. That means only component B, no component A. And the pressure exerted by this component B is PB naught. And we have assumed that PB naught is higher than PA naught. It may be the reverse also. Now, for Raoult's law, if the solution obeys Raoult's law, then we are supposed to get, as chi A is decreasing, PA is also decreasing. You see, these dotted lines is continuously decreasing. But since it is not following Raoult's law, what is happening? PA is more than PA naught chi A. So the line is above the line which is expected. The dotted line is the expected line, but the curved line is the reality. It is a parabolic line, you can see. Exactly the same way as chi b is increasing from here to here, the PB is also expected to increase. But it is increasing, but not following Raoult's law, you see. It is not following the straight line, rather it is forming a parabolic path. Now what happens? Then how much will be the pressure, total pressure? The total pressure will no longer be PA plus PB. It will be, you see, above the PA-PB line, and it is also forming a curved line, parabolic curve. Now here you see at certain point of time where the vapor pressure is maximum. Alright, at this point the vapor pressure is maximum. Now if you drop a perpendicular on the mole fraction axis, this is the percentage at which the vapor pressure is maximum, so they will form a azeotropic mixture at this point. Since the vapor pressure is maximum, boiling point will be minimum. So this is the situation when the solution is showing positive deviation from Raoult's law and forming a minimum boiling azeotrope. The concept of azeotrope is not so simple. You need to understand, but luckily not much difficult questions are asked during exams. So you can just stick to the definitions and example and try to understand the graph. Now let us try to understand the solution showing negative deviation. You look here. Here we have taken chi A to be equal to 1 and chi B to be 0. So it is same situation, PA naught, and here we have PB naught because it is chi B to be 1. Now, as you know, AB interaction is stronger than AA and BB interaction as shown here. So what happens? What is the relation now according to Raoult's law? PA is less than PA naught chi A and PB is less than PB naught chi B. As a result, what is happening to the graph? The graph is going down than expected. The expected line is this, but actually it is going down. Expected line is this, but it is actually going down. Similarly, this is the expected line and this is going down. So you can see all the lines which were expected, the actual line is below that. So here what will happen? You'll see there is a situation when the vapor pressure is minimum. As you know, the y-axis represents the vapor pressure, and here you can see somewhere the vapor pressure is minimum. So if the vapor pressure is minimum, the boiling point will be maximum. So this is the composition of certain value of chi A and chi B. They will form a azeotropic mixture where the boiling point will be maximum, and such a situation is called, or such a composition at which they have a maximum boiling point and they form a azeotrope is called maximum boiling azeotrope.